Math 8, Unit 4, Graphing and Slope, Lesson 1, Introduction to Graphs, Two Variable Equations. I can graph a linear equation using a table of values. That's what we're going to be going over. Now, a couple of things that you should understand. Two variable linear equations are of the form y equals ax plus b. That's one of their forms anywhere. A and b are real numbers and x and y are the variables. They represent your x and your y-axis. A graph of a two variable equation is a picture of the solutions. I'm going to explain that in just a sec. And you can check a solution by plugging x, y into the equation to see if it makes sense for your statement. Let's consider the equation. Now this isn't in the form that I explained of y equals ax plus b. I just have an equation with two variables, x plus y equals 4. And let's take a look at it. Now, possible solutions here. 2 plus 2 equals 4. That would represent the point 2, 2. And that is a single point right here. Other possible solutions? 4 plus 0 equals 4. Well, that's the point 4, 0. And that's right here on the graph. We have a lot more. We could have negative 1 plus 5 equals 4. So the point negative 1, 5. Negative 1 and up 5. And all of these points here lie in a straight line. Every single one of these points that I've drawn in blue will have x plus y equaling 4. And they do all end up in a straight line. Now this line is a picture of the solutions to x plus y equals 4. That's an important thing to understand. Every single point on the solution, on the line, makes this equation true, and every point that makes this equation true is on the line. There's an infinite number of solutions here, but they're all in a straight line. This is actually why it's called a linear equation, because anytime you look at the picture of its solutions on a coordinate plane with x and y axes, you're going to get a straight line. It's a linear equation. So a linear equation is an equation whose graph is a line. The points on the line are solutions to the equation. You can use the graph to show the solutions of a linear equation. The graph below represents the equation y equals x plus 1. So in every one of these points on this line, y equals x plus 1. Y is greater than x by 1. You can see negative 1 is 0. 0 becomes 1. 2 becomes 3. Every x you just get one more for the y. And it represents this, is represented by the picture of the solution. Remember, the graph is a picture of the solutions to the equation. Okay, name a solution to this linear equation. Well, there are 4 of the solutions plotted. We've got this one right here at negative 2, 4. So that's a solution, negative 2, 4. There's also a solution right here at negative 1, 1. There's a solution at 0, negative 2, and a solution at 1, negative 5. There are also solutions if you keep the pattern going, and there's solutions in between, like 0.5 and negative 2.5, negative 3.5, right there. And we will later in this unit learn how to come up with this, but this graph is a picture of the solution for y equals negative 3x minus 2. And every single one of these solutions that I wrote down will be true when plugged into this. If I plug in y is 4 and x is negative 2, right here I get 6 minus 2, which is 4. That's true. If I try negative 1, 1, plug in 1 for y and negative 1 for x. Whoops, negative 1, not negative 3. Negative 1 for x. This is negative 3 times negative 1 is 3. 3 minus 2 is 1. That checks out. If we try in the negative one, next one, negative 2 is negative 3 times 0 minus 2. This is just 0 minus 2, and that works out to be negative 2. Negative 5 should be negative 3 times 1 minus 2. That's negative 3 minus 2, which is negative 5. Every single point on that line is going to make this true. Just plugging in your y and your x. And it makes the equation true. Okay, in a real-life model, each solution represents a possible reality. Not necessarily an actual reality. This line would go on forever. This point that I have drawn would represent, we'll follow it down to the x-axis, 5 pizzas, $30. It means that 5 pizzas cost $30. The reason I say it a possible reality is the math will go on forever. We could get the number, let's do 1,000. Probably shouldn't put a comma in there. 1,000 pizzas would be $6,000. Now that is a possible reality. I don't think anyone's really bought 1,000 pizzas all at once. I mean, they could be talking about having sold 1,000 pizzas, but it's a possible reality based on the information given. Here's a helicopter. Well, it says helicopter at the top. The x-axis says time, and it's measured in seconds. It goes from 1 to 7. The height of the helicopter is measured in meters. Looks like we're counting by 5s and going 5 up to 35, interpreting these points. So, it looks like a helicopter going down. A helicopter must be landing. So this point right here means that at 2 seconds, the helicopter is 25 meters off the ground. This next point, B, it means that at 5 seconds, the helicopter is 10 meters off the ground. And this last point, C, means that at 7 seconds, the helicopter is at 0 feet off the ground. We would probably actually say the helicopter lands after 7 seconds. Okay, now when we graphing with a t-chart, step 1 is to make a table of values. So we're going to graph y equals negative 2x plus 1. We start with a table, sometimes called a t-chart. We just made a lowercase t, and we're going to put x's on the left and y's on the right. And we need to just pick values for x. A really great one to pick is 0. This would be y is negative 2 times 0 plus 1. Negative 2 times 0 is 0. 0 plus 1 is 1. Let's do another point. Let's try 1. Y equals negative 2 times 1 plus 1. This is negative 2 plus 1 is negative 1. Let's try 2. If we plug in 2 for x, this is negative 2 times 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Okay, let's plot these points. Before I plot them, though, I'm going to number and label my axis. This is the x-axis. Looks like we've got positives and negatives. Here's the y-axis. Let's see, this would be 1, 2, 3, 4, 5, 6. And I can go down into the negatives as well. Negative 3, 4, negative 5, negative 6. Okay, so we've got our numbers on our graph. The first point is the point 0, 1. So I go to 0, 1, and that's my first point. The next point is 1, negative 1. I go to 1, negative 1, and there's my next point. Then I've got the point 2, negative 3. I go to 2 and then down to negative 3. So the first step is to make the table of values. Then you plot the ordered pairs. Then you're going to use the pattern you see to make more dots and then draw your line. I see a pattern here of down 2, right 1. And we can keep that pattern of down 2, right 1 going and get another point here. We can go up 2, left 1 to get these additional 2 points. And now we've done as many dots as we can with the pattern. And we can connect it, and we've got a nice straight line. We now have a picture of the graph y equals negative 2x plus 1. Okay, let's do another one, following the same process. Step 1, make a table of values. Well, for x equals negative 6, let's first pick an x of 0. If I plug in 0 for x, I get 0 equals negative 6, which of course is false. There's no solution there. When x is 0, there's nothing y can be. And we can try this out with 1 as well, and it's not going to work. But if we try in negative 6, this is true. Because it's true, y can be any number at all that we want. Okay, it could be 0, could be 1, could be 2, anything we want y to be. Now what this ends up looking like is at negative 6 on the x-axis, we are going to have a line to draw. I'm just getting some numbers written on the graph here. So at negative 6, 0, negative 6, 1, and negative 6, 2, I've got 3 points on this line. Now there is enough here to see a pattern. I can keep the pattern going up and down, and it looks like it gives me a vertical line. By the way, x equals a number. I'm just using a here. If x equals some number, it's just going to be a vertical line. Okay, if y equals a number, let's do a t-chart here, a table. If we pick an x, let's try 0. If we plug in 0, y equals 6.75. Let's try 1. If we plug in 1 for x, we get y equals 6.75. In fact, no matter what we put in for x, we're always going to get y equals 6.75 because it doesn't depend on what x is. Okay, as far as our graph goes, let's throw in an x-axis here, and we'll also have a y-axis. Let's put some labels on them here. Let's just count by ones, but save a little bit of time by labeling every other one. So 2, 4, 6, 8, 2, 4, 6, and negative 2, negative 4. All right, we're good. Now, graphing this, 0 is 6.75. That's a little bit under 7. 1 is 6.75. And 2 is 6.75. From the pattern here, we can see it's just going to keep going across, back and forth. It is a horizontal line. So if you have y equals some number, here I'm going to use a b, then you get a horizontal line. Y equals a number is a horizontal line. Okay? So here's a summary of the last two examples we looked at. If you've got a horizontal or vertical line, if it is a y equals a number, you get a vertical line or horizontal line through the point 0, comma b, whatever that number it equals. If you get x equals a, it goes through the point a, comma 0, right on the x-axis, and then it's a vertical line. Okay, the wind speed y in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. Graph the equation. All right, in order to graph this, let's see, let's just extend it down a little bit. What is that thing? Let's get it out of there. Okay, first thing we would do is make a table. X is the number of hours, right? Let's actually go ahead and label the x-axis with hours. And the y-axis is wind speed. I'll go ahead and label that. Okay, at 0 hours, I plug in 0, 2 times 0 plus 66 is 66. Plug in 1 hour. 2 times 1 is 2. 2 plus 66 is 68. At 2 hours, I get 2 times 2, that's 4, plus 66 is 70. And we can actually see a pattern going here. It's going up by 2, while this goes up by 1. Okay, nice. As far as graphing it goes, I'm just going to, let's not put 0 there, we'll put 0 right along the edge. And I'm going to label every other one as a full hour, so I guess I have half hours here. And since these are 66, 68, 70, I'm going to put a break in my graph, and I will start out at 66. 67, 68, 69, 70, whoops, 70 doesn't look like that. It's got a 7 in it. And then 72, 74, 76, 78, 80 would be right up here. Okay. And then plot the points from the graph, or from the table. 0, 66 is right here. 1, 68. 2 is at 70. And 3 is at 72. And it looks like we get a nice straight line. Very good. Now, question is, when does this become a hurricane? A tropical storm becomes a hurricane when wind speeds are at least 74 miles an hour. So 74 miles an hour is right here. Anytime the speed is higher than that, it is a hurricane. Down here, it's a tropical storm. So it will become a hurricane once it passes this point, which will happen after 4 hours. So 4 hours is how long it'll take to become a hurricane. Okay, let's do another graph. Y equals 1.5x minus 2. We start with a table. Let's go ahead and try 0. 0 is a great number to always try. This is 1.5 times 0 minus 2. That's 0 minus 2 is negative 2. If we try 1, 1.5 minus 2, see this is times 1, is negative a half. Let's try 2. If I try 2 in, 1.5 times 2 is 3. 3 minus 2 is 1. Let's plot these points and see what that gives us. We need an x-axis. We need a y-axis. Let's just go ahead and throw some numbers on there. I'll just go 2 and 4 and 6. 2, 4, 6. Negative 2, negative 4, negative 6. Negative 2, negative 4, negative 6. Okay. At 0, it's at negative 2. At 1, it's negative a half. At 2, it's 1. There's actually a really good pattern between these 2 points of going up 3 and over 2. So I'm going to use that pattern to go up 3 over 2 again, and down 3 and back 2. And this gives us this nice line, and that's graphed. Remember, make the table, plot the points, use the pattern in the points to make more points, then draw your line. Okay, for this one, x and y, I'm going to use 0, which is great. 1/4 times 0 is 0. If I try 1, 1/4 times 1 is 1/4. It's actually good to use multiples of the denominator 4. 1/4 times 4 is 1. And let's plot those. So we've got the x-axis, the y-axis, and this 2, 4, 6, negative 2, negative 4, negative 6, 2, 4, 6, and negative 2, negative 4. Okay, it's all nicely labeled. And we've got 0, 0, 0, 0, and 1, 1/4. That's going to be kind of right there. And 4, 1. Using the pattern, I can see I get another dot over here, and I can draw my line. Okay, in the practice, we're going to graph. This is for graphing by T-chart. Number 1, you make the table, you draw your axes, you plot the points. Number 2, you're doing the same thing, but on number 1, I gave you x values to plug in. On number 2, you get to pick your own. Number 3 is a review, solve for y. We're going to be doing that later in this unit. Number 4, write the ordered pair for each point graphed. There's 4 of them there. Where is A located? Where is B located? Just write the x, comma, y ordered pair. Number 5, find the volume of the triangular prism. Remember, it's base area times height. The base is a triangle, and the height would be 12. Number 6, translate each graph line segment the given amount. So instead of being a triangle, we're going to translate just a line segment. Number 7, which equation will produce the given graph, and how do you know? So this is multiple choice plus an explanation. And number 8, fill in the blanks so each equation would graph the point 4, would be through the point 4, comma 2. So you fill in the blank there so that it will have that as a solution.